So, proof by principle of mathematical induction (P.M.I) that 1 square plus 2 square plus 3 square plus up to n square is n plus 1 2n plus 1 divided by 2, where n is a member of natural number. That is, sum of the square of first n natural number is n plus 1 2n plus 1 divided by 6. So, given 1 square plus 2 square plus 3 square plus n square is equals to n plus 1 2n plus 1 divided by 6. So where n is a member of natural number. So as usual, we have 3 steps. So step 1, show that the given statements is true for n is equals to 1. So to show that the given statement is true for n equals 1, so you have left hand side. So first term, that is for n equals 1, so we have 1 square there. That is the first term. So 1 square is 1. Also right hand side, we have n plus 1 2n plus 1 divided by 6. So for n equals to 1, so we have 1 plus 1 2 times 1 plus 1 divided by 6. So this is 1 bracket 2 plus 1 divided by 6. So this is 1 bracket 2 bracket 3 divided by 6. So this is like saying 1 times 2 times 3. So 1 times 2 2 2 times 3 6. That is 6 divided by 6, and that is 1. So we have seen that for n equals to 1, left hand side equals 1, right hand side is also equals to 1. So that means the statement is true for n is equals to 1. So now that we show that left hand side equals to right hand side, so we will now conclude that is 1. So we conclude that the given statements is true for n equals to 1. So this is for step 1. Now step 2. So you can write it in your notes so to get it step by step. So now step 2. Assume that the given statement is true for n is equals to k. Remember, if you are proving that it's true for n equals k, you will rewrite everything like your question, but change all the n to k. That's just the difference. So write all the question but change everything to k. So assume that the given statement is true for n equals k. That means 1 square plus 2 square plus 3 square plus k square is equals to k plus 1, 2k plus 1 divided by 6. Do you see it's like I rewrite everything here but I only change n to k. So that is how you prove for if it is true for n equals k. So you now say for k is a member of n. So after writing this, then you conclude the given statement is true for n equals to k. So we have proved step 2 like that. Now step 3. That is where we now have a simple manipulation. So now step 3. Assume that, so we have assumed as in the assumption made in step 2, show that the given statement is true for n equals to k, n equals to k plus 1. So that's a step 3. So watch the video on the video 1, 2, 3. So you follow it step by step before this video. So I'm numbering it 1, 2, 3. So I'll still do more example, but follow from beginning so you can understand this pattern. It's the same thing I'm doing throughout. Now this step 3, using the assumption made in step 2, show that the given statement is true for n equals k plus 1. So left hand side, so we have 1 square plus 2 square plus 3 square up to plus k plus 1 square. So that is n square. So I'm just writing the left hand side, everything here. But remember n is k plus 1. So that n square will become k plus 1 square. That is left hand side. So, and I told you that I will only rewrite this step, but I'll put brackets here, as in that's what I'll write in my next step. So in the next step I'm rewriting everything here, but I'm only putting brackets. So that will be 1 square plus 2 square plus 3 square, so brackets plus k plus 1 square. So if you watch the video I've been doing here, 1, 2, 3 video, you will see this step 3, you will only rewrite the left hand side and put brackets after the dot dot dots, so leaving the plus out. So now if you look at everything inside this bracket now, it's like what you have here, but it's not complete now. So the completion of this is n square, but here is k we are using. So if I want to complete what we have here now, I'll add plus k square so that we actually be like this. So that will be my next step. So next step now, so next step, so instead of writing everything in this bracket now, So I'll write it and complete it. That is 1 square plus 2 square plus 3 square. So plus, it's dot dot dot. So I'll add plus k square because I have plus n square. So but now is in terms of k. So that will be plus k square. So I've completed what I have in the brackets now. So I have plus this one outside. So that will be plus k plus 1 square. So like that. So if you now look at everything you have in the brackets now, yeah, it's now similar to what you have here. But all this sum is equals to n plus 1 plus 2n plus 1 divided by 6. So that means all this expression here will becomes k plus 1 2k plus 1 divided by 6. So it will be equals to this. So but in terms of k, so that's what we'll write in next step. So that's our next step. So I have this is equals to, so instead of writing everything in this bracket, so I will now write this expression. So this will becomes k plus 1 2k plus 1 divided by 6. That is all this expression, then plus that one outside, so plus k plus 1 square. So that is it. So next step, so you can factor out k plus 1 out. That is k plus 1 over 6. Remember, I have k plus 1 here. I also have k plus 1 here. So I can say k plus 1 is common. And I can remove this 6 outside too. So this will becomes k plus 1 divided by 6. Then open a big bracket. So if k plus 1 over 6 is common here, it will remain k and 2k plus 1 there. So that means it will remain k bracket 2k plus 1. Then plus, remember k plus 1 is common and we say over 6. So that means this must be 6 bracket. It will remain just 1k plus 1 there. So because there is no over 6 here, so and we say over 6 is common, so I have to put 6 here so that it will go. That is the 6 here. Remember, 6 times 6 over 6 here will cancel out, so that's why 6 is there. So remember, again, you factor out k plus 1 over 6, so it will remain k and 2k plus 1 here, which is it here. Then plus, I have to put 6 here so that we cancel this 6 since 6 is not here. So and 1k plus 1 is out, it will remain just 1. So like that. So now expand this bracket inside. So we have, so next step, so next step now. So I have to jot everything down step by step. So this is k plus 1 over 6 brackets. So I'll have to expand everything in the brackets. Yeah. So this will be 2k squared plus k. So k times 2k, 2k squared. K times 1, k plus 6k plus 6. That is 6k times k, 6k. 6 times k, 6k. Again, 6 times 1, 6. So next step, we have 2k squared, 1k plus 6k, that's 7k plus 6. So that's what we have next. So we just add everything here. Now what we have inside is a quadratic equation. So like I said, watch my video on factorization of quadratic equation so you can understand how to factorize better. So I've done it in details, but yeah, we are just going to solve. So now the next step, we are going to factorize what we have in the brackets. Yeah, so yeah, factorize everything here. So make sure you jot so you can understand it step by step. So factorize this, we have 2k squared plus 4k plus 3k plus 6, because if you multiply the first and the last time you get 12. 2 times 6, 12, while the middle is 7. What are the two numbers you multiply to get 12? If you add, you get 7. 4 times 3, 12. 4 plus 3, 7. That's why I'm replacing this middle 7 with 4 and 3. So watch my video on factorization to understand the factorization better. So now the next step, brackets 2 2. So after you have get your factorization, so you have to bracket 2 2. So now after you bracket it 2 2, then find what is common in each bracket. So what is common in each bracket? Brackets. So now 2 is common here. Also k is common. So that will be 2k is common. So it remains k plus 2. Then plus 3 is common here. Then it remains k plus 2. Please, if you don't know how to factorize, go and watch my video on factorization so you can understand that step very well. So k plus 2 is here, k plus 2 is here, is common. So I'll take 1 out of the 2. So now take 1 out of the 2k plus 2. So we have k plus 2. Also take the outside number, 2k plus 3. So that will be 2k plus 3. So like that. So in the next step, split everything to k plus 1 times. Split everything there to k plus 1 times. So we have brackets. So remember this k plus 2 now. I can say k plus 1 plus 1. So why are we doing that? Because we remember we are using n equals k plus 1 for the third step. So that's why I'm splitting everything to k plus 1 time. So now k plus 2 now is k plus 1, k plus 1. While 2k plus 3 will be 2k plus 1 plus 2, as in 2k plus 3. So let me do it this way. 2k plus 3 is the same thing as 2k plus 2 plus 1. So remember, 2 plus 1 is 3. So next step, so if you look at this place, this one, you will notice 2 is common there. You will notice 2 is common here. So bring 1, 2 out. So it remains k plus 1, then plus 1. That is, remove 1, 2 out. So it remains k plus 1. So 2 times k, 2k, 2 times 1, 2. Go back to that one, then plus 1, like that. So that's what we did there. So if you look at everything now, I have it in terms of k plus 1. So now, according to the step 3, so we are proving the induction for n equals to k plus 1. So when n equals to k plus 1, so that means all the k plus 1 I have here, I'll change it back. So this will be 1 square plus 2 square plus 3 square plus n square. So that is this k square. So k plus 1 is n, like n square. So will be equals to, so k plus 1 over 6, that will be n over 6 bracket. So this k plus 1 is n. So that will be n plus 1. So 2, then k plus 1, that is n. That will be 2n, then plus 1. So I've replaced all the k plus 1 here as n. So I've replaced it as n. So now finally, everything here will be divided by 6. So finally I have 1 square plus 2 square plus 3 square plus n square equals to n plus 1, 2n plus 1 divided by 6. So which is equals to the right hand side. So since the left hand side equals to this right hand side here, so we have proved. Therefore, the given statement is true for n is equals to k plus 1. So after that, so we'll just conclude finally. Therefore, Therefore, 1 square plus 2 square plus 3 square up to n square is equals to n plus 1 for n is a member of natural number is true by P.M.I. So done. So move on with another example.